Okay, so now we're going to talk about the not easy cases. I mean, they're not easy. They're pretty simple too. But they're not as simple as adding to head, right? And so let's talk about cases where we have to traverse the whole linked list, okay? That might be add to tail, where we're looking for the node that's pointing to null, so we can add to the end of it. That might be count, right? Where we're trying to count the number of 4s in the linked list, for example. That might be something like, toString that you did, right? Or the function I did, which was the thing that printed it out to the screen so you could see what was going on with your particular linked list, okay? So let's talk about this. And the method is always the same. There's a little differences to it, but the method's always the same. So let's say you were doing that count one. You wanted to count the number of things, okay? So we have head pointing to 4, which points to 2, which points to 4, which points to null, okay? Really simple linked list there, right? You like the wires? Pretty ugly. Okay, so what we're gonna do is, the first thing we're gonna do is we're going to point a node to the head, okay, and we're going to call that current. So point current node to the head, and meaning that current and head reference the same node, okay? It's a shallow copy. Current right now is a shallow copy of the head. And then what we're going to do is we're just going to keep on moving current until it hits the null and we're done, okay? We've gotten through the whole linked list at that point. Okay. Notice we're not moving the head. In fact, we never move the head, because if you move the head to point to this, for example, you've lost the first node, unless you have something pointing to the first node. You never move the head. Head always points to either the first node or null in an empty list case. Okay. Those are the only two things head ever points to. All right. So then the second thing we do is we say some sort of while current is not referencing null, okay, and then we are visiting the current node, so we do whatever we want to do in the current node, whatever processing we want to do on the current node. Okay, so you do whatever processing you want to do on the current node, and then, we're still in the while loop, sorry. Then you make current equal to current's next. Okay, and after you're done with that, you return whatever you want to return, or print whatever, right? So at this point of the while loop, you have traversed through the linked list, okay? At this point, you have traversed through the linked list, okay? So, when you leave the while loop. So at this point, I'm sorry, it'll just get confusing because the while loop's not. At this point, you have traversed through the linked list, right? You understood what I meant. He said, hopefully. So does that make sense? So we're going to do another fill-in-the-blank question, which goes through this, and we'll do it for a few different cases. Now, there's two different things that happen here, right? Or actually, there's three different cases now with this. That you have to kind of think about. So one is, if I'm going through the whole linked list, I can just say when current equals null, okay? Actually, let's do the whole linked list version, and then we'll talk about the other two versions of this in the next video, all right? See you there.